Now I'm ready to try practice problem 13. It says a gas occupies 61.4 milliliters at 67 degrees Celsius. So there's a V1 and T1, and it's at 96.8 kilopascals. I need to recognize that that's a pressure. And it says find the new volume. So that's how I know I'm going to be using ones and twos, initial and final conditions. So I don't know what the new volume is, V2, but I've got T2 as 0 degrees Celsius and P2 as 52.2 kilopascals. Now I'm still going to list them here. V1 is 61.4 milliliters. T1, 67 degrees Celsius plus 273 is 340 Kelvin. 340 Kelvin. P1 is 96.8 kilopascals. I don't know V2, but T2 is 0 degrees Celsius. I'm going to convert it to Kelvin. Always convert to Kelvin because that's our absolute temperature scale. 273 Kelvin, and then P2 is 52.2 kilopascals. Then I'm going to plug that all in to P1 V1 over T1 equals P2 V2 over T2. So pressure 1, 96.8 kilopascals. V1, 61.4 milliliters. And T1 is 340 Kelvin. P2 is 52.2 kilopascals. V2 is my unknown. I'm going to try to solve for V2 here. And T2 is 273 Kelvin. Now I just cross multiply. So let's try this side first. And I'm going to go down here where I have a little more room to put my result. So I'm cross multiplying and I'm going to get 340 Kelvin times 52.2 kilopascals times V2 is equal to, in the other direction, 273 Kelvin times 96.8 kilopascal times 61.4 milliliters. Okay, now to get V2 alone, I've got to divide both sides by 340 Kelvin and by 52.2 kilopascals. Over here, divide by 340 Kelvin and 52.2 kilopascals. And that gets V2 all alone, so I have solved for V2. If I check out my units, Kelvins cancel, kilopascals cancel. My units are milliliters, which is great because I've solved for a volume. And when I plug all that in my calculator, where this is my whole numerator and this is my whole denominator, for V2 I should get 91.4 milliliters. So that's how you use the combined gas law for a set of initial conditions and final conditions.